Assalamu alaikum. Class, this is the last lecture of biostatistics, and practically this is the last lecture of your section, in which we will be discussing chi-square test. As I have already mentioned in my last lecture, that these tests of significance give us the p-value, and on the basis of p-value, we accept or reject our null hypothesis. Majority of the times, we are dealing with qualitative data, and if we are dealing with qualitative data or categorical data or nominal data or ordinal data, which are all subtypes of qualitative data, we apply tests of significance, which is known as chi-square test of significance. And practically, this is the most common test of significance which is utilized worldwide by the researchers. If we are dealing with quantitative data, then we will be dealing with z-test and t-test and ANOVAs, which we have discussed in detail in our last lecture. Calculation of chi-square test manually is part of your syllabus and which we will be covering today. Majority of the times, the value of p's are calculated by application of chi-square test in SPSS, which is statistical package of software in which we deal with statistical sciences. This is the software for statistical sciences in which we calculate the p-values by putting our data. But today we will be discussing the application of chi-square manually and how do we interpret it. So moving forward, I will be giving you small assignments and which will be finished by the end of this lecture. So please move forward with me. So this is a scenario in which a research was done in a pre-market trial of two vaccines against measles. So there were 200 participants and they were randomly selected into two groups of equal sizes. Those who received vaccine A and developed measles were 20, and vaccine B resulted in 15 cases of measles in post-vaccination phase. So interpret the results. Before going to interpretation of the result, let me ask you that what was the study design which the researcher has used here? So you have to answer my first question, that what is the study design the researcher has used in this particular study. Okay, so now this is the scenario. The first component will be that you will state null hypothesis, which is H naught. So what will be your null hypothesis? Please write it down. So state alternate hypothesis, which is H1. Ideally, it should be that there is no difference in the prevention of measles between two vaccines, and alternate hypothesis will be there is a difference between vaccine A when we compare with the rates of development of measles as compared to vaccine B. This will be your alternate hypothesis. Okay, so move forward. Step 2 will be construct contingency table. And you all know what is contingency table? Contingency table means 2 by 2 table. So let me show you the data again. This is the data. And now you have to construct 2 by 2 table. If you have constructed 2 by 2 table, let's move to the table now. This is the vaccine A. This is the vaccine B. The total number of participants were 200, and these participants were randomly distributed between two groups of 100 and 100 of equal sizes. So the study design will be randomized control trial. Why randomized? Because randomization is done. Why control? Because there is a control group, and Trial, because the researcher is doing some intervention which will alter the outcome. He's introducing a vaccine which will alter the disease status. So what will you do? As we construct 2 by 2 table, diseased and no disease status is always labeled in columns, and then the risk factors or the vaccines or other things are placed on the rows. So vaccine A was given to 100 people and out of 120 developed disease, and vaccine B was given to 100 people and 15 developed the disease. So you will calculate the non-diseased population yourself. You will complete the row total and the column total and the grand total. Until and unless you complete the 4 columns and 4 rows of 2 by 2 table, you are not done with your 2 by 2 table. If you will not construct 4 rows and 4 columns, your marks will be deducted. So be very, very vigilant when you are drawing or constructing 2 by 2 table. Okay, one of the component can be that you can calculate the efficacy of vaccine A by calculating the disease status in percentages with vaccine A and disease status with vaccine B in percentages. But at this particular time, we want to calculate that is there any statistical difference between the efficacy of these two, or is there any no difference between the statistical between the efficacy of these two. So we will be applying test of significance, and as the data you can see is categorical data, qualitative data, and nominal data. So we will be deciding that we will be applying chi-square test of significance, and we will fix p-value. If you are dealing with 95% confidence interval, your p-value will be 0.05, and if you are dealing with 99% of confidence limits, then your p-value will be fixed at 0.01. So as all the researchers do in their routine work, their work with 95% confidence interval, so we will be dealing with 95% confidence limits, and we will fix our margin of error at 0.05. So we have decided our p-value, we have decided our test of significance. So now what we will do is that now step 4 is calculate expected value of each cell. Look at this, these are the observed values. Fine. Now in 2 by 2 table, we will calculate the expected value. And how do we calculate the expected value? Expected value of each cell will be calculated as row total into column total over grand total. So I am repeating, the expected value of each cell will be calculated as row total into column total over grand total. So this was our observed values. This and this were our observed values, and now we want to calculate the expected value. So expected value for this particular cell will be row total, which is 100, into column total, which is 35, divided by grand total, which is 200. Fine. So for this particular cell, the row total into column total divided by grand total. Again, for this cell, the row total, the column total into grand total, and for this cell, the row total, the column total, and into divided by grand total. So we have got the values of expected value in each cell. This is known as observed value, and this is the expected value which we have calculated. This is the observed value and this is the expected value. So for each cell, we will be calculating the expected values, and the values of expectation are calculated by row total into column total over grand total for each cell. After passing through this stage, now we will formulate the table for calculation of chi-square value. These are the cells A, B, C, D, and now For cell A, observed minus expected value. This is the observed value minus expected value. So for each cell, you will be calculating observed minus expected, observed minus expected, observed minus expected. So we will fill this column. Moving forward, now we want to take square of observed minus expected, and after taking observed minus expected whole square, we will be dividing then for the expected value for each cell. So for cell A, observed minus expected, and then observed minus expected square, observed minus expected square divided by the expected value, which will give us a value, another value. Fine. So what we will do, we will calculate the total value of all these cells, which is 0 0.8. Now we have got the value calculation for the chi-square test. Now we will calculate the degree of freedom. Degree of freedom is calculated by the contingency table, which is row minus 1 into column minus 1. And for 2 by 2 table, it is always equal to 2 minus 1 into 2 minus 1, which is 1 into 1 is equal to 1. I am repeating, the degree of freedom for each table is calculated by row minus 1 into column minus 1. In 2 by 2 table, 2 minus 1 is into 2 minus 1, which is equal to 1 into 1 is equal to 1. So degree of freedom is 1. Now we will go towards the table of chi-square value. This is the degree of freedom. This is 1. And for 0.05, which was our p value, the value should be 3.811. Our chi-square value was 0.8, which is far below this value. So with the comparison of our chi-square value with this value, we will be accepting our null hypothesis and we will be rejecting our alternate hypothesis. So there is no difference in the efficacy of both the vaccines except null hypothesis. This is your decision. So this is the way how we calculate the chi-square values. If if the null hypothesis is accepted or rejected on wrong observation, the researcher is committing type 1 or type 2 error, and the most important is the type 2 error. The probability of probability of committing alpha error and beta error is calculated by the p values, which the researcher does not want to do. And so by calculating the fixed p values, we accept or reject the null hypothesis. So we have finished the calculation of chi-square value. Normally in exams, you do not get these values to be calculated, but in previous exams, sometimes the examiner have given the calculation of chi-square value. So the probability, although of calculating probability of chi-square value is lesser manually in exams, but depending upon the choice of the examiner, a question can come to you. So you must be prepared. With this, I have finished all the things which were part of your syllabus in biostatistics, screening, research methodology, and epidemiology. With this, I officially conclude lectures of community medicine. And now we will be welcoming you after the corona pandemic and we will be having your revision tests. I wish you all the best. If you have any questions, you can come to me. I'm always available. Thank you so much.